In the name of God, hello everybody. My name is Mehdi Kortnavasi, and this is the fifth movie about the chapter 2 key principle of software architecture. And in this movie, we will talk about the quality attributes and cross-cutting concerns. Let's start. Quality attributes such as security, performance, and usability can be used to focus your thinking on the critical problems that your design should solve. Depending on your requirements, you might need to consider every quality attribute covered in this guide, or you might only need to consider a subset of these attributes. For example, every application design must consider security and performance, but not every design needs to consider interoperability or scalability. Understand your requirements and deployment scenarios first, so that you know which quality attributes are important for your design. Keep in mind that quality attributes may conflict. For example, security often requires a trade-off against performance and usability. Quality attributes are system properties that are separated from the functionality of the system. From a technical perspective, implementing quality attributes can differentiate a good system from a bad one. There are two types of quality attributes: those that are measured at runtime and those that can only be estimated through inspection. Analyze the trade-off between quality attributes.
Here are very brief definitions of some of the common quality attributes. Certainly there are many others, and they are grouped together in various ways by different authors. I encourage you to read Chapter 12 of some quality attribute categories on this slide typically are important and visible to users, so they're indicators of external product quality. Availability has to do with whether the system services are available when and where users need to use them. Availability is not black and white. Of course, everyone wants a system to be available at any time, but in reality, sometimes it's acceptable to have certain system functions that are not available at particular times or in certain locations. Installability describes how easy it is for a user to install the product correctly. Installability also encompasses uninstalling a product, reinstalling it on top of itself, installing updates or new versions on top of an older version, adding additional components after a partial earlier installation, aborting an installation partway through, and recovering from an incomplete or unsuccessful installation attempt. Installability typically is the first experience the user has with the product. There's a little heuristic I use. If I encounter problems during the initial software installation, I don't have much confidence in the overall quality of the product, and it makes me somewhat nervous to use it. Integrity addresses how well the system protects against access by unauthorized users, user privilege levels, protection from virus infection or Trojans, and protection against data loss. Security is one important aspect of integrity, but security doesn't normally encompass data integrity, so integrity is broader in scope than just security. Interoperability has to do with how easily your system can interchange data or services with other applications. We've already discussed performance as measuring how quickly the system responds or executes a given task. Sometimes performance is treated as a separate type of non-functional requirements, other times it's included as a quality attribute. It really doesn't matter very much, so long as you address it. Reliable systems can be used for a long time, maybe forever, before a user experiences some kind of a failure. But if the user does experience a failure, how easily and quickly can he recover from that failure and continue working? Robustness describes how well the system responds to unexpected operating conditions. Fragile systems do not handle invalid entries very well, but robust systems do. Sometimes when users are describing a system as handling errors gracefully, they're thinking in terms of the robustness attribute. Safety is an issue of how well the system protects people against injury or death, or whether the system avoids causing damage if it encounters a problem. People are rarely injured by exploding spreadsheets, but real-time systems that include hardware and software components have very real safety concerns. Usability is a very large attribute domain that encompasses both ease of learning and ease of use. The arena of usability and human factors in the human-computer interface has been well studied, and there's a very large volume of literature in this area. Usability goes far beyond the colloquial term of user-friendly. So these quality attributes are primarily important to the user's experience with the product, the external quality of the product. Here's another set of quality characteristics that relate more to the internal quality of the product. So these are particularly important to developers and support staff. Indirectly, of course, these attributes have an impact on the user's ability to get value from the system in a happy kind of way. Efficiency addresses how well the system utilizes computer resources such as processor capacity, disk space or other storage media, memory, network or other communications bandwidth, and so forth. Efficiency directly relates to the user's perception of performance. By flexibility here, we are not referring to end-user flexibility in their tasks, but rather how easy it is to update and modify the system to add new functionality. Similarly, maintainability has to do with how easy it is for developers or support staff to make changes in the software or to correct errors that are discovered. Maintainability is influenced by how easy it is for someone besides the original author to understand the software code and other artifacts. Portability, of course, addresses how easily developers can make the software run on platforms or operating systems other than that for which it was originally intended. Reusable software makes it easy to take components from the original application and use them in some other application. Scalability is a matter of whether we can add additional capacity to grow with the user base. How easy is it to support more concurrent users without compromising the system's performance? Can you readily plug in more output devices or input sensors than it was originally intended to control or monitor? Can you move the software onto multiple servers or databases to meet the needs of a geographically distributed and growing user population? Supportability broadly addresses the ability to effectively support the application after it is in use. Is it easy to make changes, install patches, assist users, and so forth? Finally, testability rates how easily we can determine whether the software was implemented correctly and is operating as expected. As you can see, there are many dimensions to software quality. I've seen lists of nearly 50 quality attributes. No one's going to worry about 50 attributes on a typical software application, but it's important that you be able to specify quality expectations in several dimensions that are important to the success of your project.
The next key design consideration is to determine the cross-cutting concerns. Cross-cutting concerns represent key areas of your design that are not related to a specific layer in your application. For example, you should consider implementing centralized or common solution for the following: a logging mechanism that allows each layer to log to a common store or log to separate a store in such a way that the results can be correlated afterwards. A mechanism for authentication and authorization that passes identities across multiple layers to permit granting access to the resources. and exception management. Framework that will work within each layer and across the layers as exceptions are propagated to the system boundaries. A communication approach that you can use to communicate between the layers. A common caching infrastructure that allows you to cache data in the presentation layer, the business layer, and the data access layer. We will discuss more in chapter 4 about the cross-cutting concerns, but as I mentioned, just the authorization, authentication, and error handling is a very important key design concerns, we say, as a cross-cutting concerns. As you see in the picture, when the authentication request issue and the result will be propagated into the other layers like application users or end users, and to decide is it right to access another resources for these users or no. Or if an exception or error happened during the runtime, error handler module may be alert and monitor the exceptions and analyze and correct if possible, or change the runtime process manner with another way, or stop the running the program and generate some documentation for administration to trace the root cause of the error or exceptions. And in this movie, you can watch the security manager controls the all security issues during the all layers and components in the applications. Cache is a fast and expensive memory to execute the programs, and as you see, one of the concern is in how to cache each layer of the application run to be improve the speed of the execution of the program. Which part or layer of the application, such as data, business, and presentation layer, need to page in, page out from physical storage or the network resources into the memory to increase the performance of the execution of the program. Okay, we will talk more about the cross-cutting concerns in the chapter 4. Thank you for watching this movie.